is ready. The 1,001 pre-launch preparations are completed. And now the army of specialists, who function with clockwork precision, wait as one for the missile.
Turn on the searchlights and clear the area.
T-minus 30 seconds and counting. 5, 8, 7, 6. Ignition. 5, 4, 3.
Atlas begins to roll seconds after launch, aiming its belly equipment pod in the direction of its target. Then it begins pitching over, a gradual tilting until normal flight attitude is achieved. As it climbs, it sends back a constant stream of flight performance information for recording on miles of magnetic tape. This detailed history of temperatures, vibrations, fuel flow rates, pressures, positions, and attitudes will be the basis for proving out new systems and modifying others. Atlas is now far beyond human sight, traveling nearly 16,000 miles per hour. It's seen only by powerful cameras watching a signal light indicate its path across the sky, and by tracking radar whose searching beams trace its passage. Now the nose cone separates from the missile. Moving 3 times faster than a bullet, it streaks alone along a ballistic trajectory to the target. And the spent Atlas, its purpose served, plunges back into the atmosphere to fiery destruction. But before its final plunge, it provided invaluable information needed to improve missiles of the future. While the weapon Atlas stands in silent vigilance at combat bases, the research Atlas is shouldering ever-increasing workloads of civilian and military space projects. It earned its place in space programs in December 1958, when an entire missile was launched into orbit around Earth, carrying the now famous Christmas message from President Eisenhower. One of its most dramatic roles as a space vehicle booster is in Project Mercury. For the Mercury program, it will thrust manned capsules into orbits around the world. The orbital flights will lead eventually to permanent manned satellites in space. In another space project, Atlas is boosting Agena series satellites into orbits. Each mission is named after the satellite carried aloft. The first was Midas, a warning system satellite which uses infrared sensors to detect enemy missile launches. The biggest load Atlas will power aloft in the years immediately ahead is Centaur, our first high-energy space vehicle. Burning liquid hydrogen for fuel, Centaur is capable of placing 9,000-pound satellites into Earth orbits and of sending large scientific probes into deep space. Current missions planned for the space rocket include flights to the Moon, Venus, and Mars. The intercontinental ballistic missile Atlas was born from the labors of many Americans and rushed to maturity at a grueling pace. It came of age in a time when its presence is vitally needed. Its awesome destructive potential guards our frontiers today. And it is capable of extending those frontiers to space tomorrow.